we are good with the, sorry, this is not linear regression. Canon classification with the train and test split. So here we have gone through with the step first. We always need to required modules. So you have to import required modules. Then after you have to load and understand the data. Then after you have to split data and training data. Why we need to split and training data? Anyone can give the answer. Why?
Yes.
Yeah. Okay. So earlier I have already shown what kind of issue you will face if you are not training, if you are not splitting your data into training and testing. So for training and testing, we have a model selection, train and test. According to data, you can easily split your data. Yeah, 1 second, I'm plugged in. 1 second, it is low. 1 second. Um, Hello, am I audible? Okay. So here we are good with the how to split the data from training and testing. Okay, then I described here what is test size, what is random state, what is stratify. Then you have to fit your model. Once your model has been fitted, then you have to then you have to predict the labels. Okay, then you have to predict the labels. Once your label has been predicted, then last step is, then what you can do that you know that predicted means this is your result. So whatever tested data you have given to machine and what is the predicted data, you have to check accuracy. You have to check accuracy. How can you check that accuracy? How can you check that accuracy? That accuracy you can check one by one, but here in machine learning, here in machine learning, there is a one function is called accuracy underscore score. One function is called accuracy underscore score. So what accuracy underscore score does? According to accuracy underscore score, you have to pass y underscore test. That means this is the tested data, and y underscore predictor. This is the data which is given by the machine, right? Then after you can say this is our accuracy. This is our accuracy. Got it? So last session we have gone through with the this concept. Is there any issue? Any doubts? Venkat? Okay, Ashif, no doubt. Anyone? Anyone? Any doubts? Ready? Jashwant? Any doubts? Okay. Okay. Good. So next issue is like I want to know that how like let's suppose your neighbor is 6. So how can you know that your neighbor should be 6, 5, 8? Okay, as we know that I have already said like let's suppose you want to change your neighbors here, so it may be impact your accuracy result. It may be impact your accuracy result. So how can you identify the number of your neighbors? How can we identify the number of your neighbors? So let's see. This is our additional. Yeah, the same things. Let me. No, this is the different one actually. This is also different. No issue. Here, let me. I want to. So I want to know. Let me. So next one is hyperparameter. Next one is hyperparameter tuning. Next one is hyperparameter tuning with the grid search CV. Grid search CV. So this is grid search CV. This is the algorithms we'll see today. Okay, we'll see today hyperparameter tuning with the grid search. Okay. So before that, I want to import. I want to import the required modules because for hyperparameter tuning you have to need this modules. So let me import here. Okay, execute here. Then I want to know. I want to observe here KNN. I want to observe here K neighbors classifier. 1 second. First one is executing actually. Okay, done. Type K-near classifier. I want to know the K-near classifier. So you can see here in K-neighbor classifiers, you can see here these are the parameters. Neighbors is a parameter. So we'll see this all parameters one by one. As of now, we are good with p is equals to 2. What is p is equals to 2? We are already familiar. As of now, we are good with the algorithm auto. But I will describe what is algorithm auto, what is B tree. Okay, get tree. So we'll see. Okay, we'll see if matrix Minkowski we are good with. I think you don't have any doubts. Okay. So today I will start how we'll decide n underscore neighbor equals to 5, n underscore neighbor equal to 6, n underscore neighbor equals to 7. We'll see today. So before that, I want to know what is the meaning of what is the meaning of tuning? What is the meaning of tuning? Anyone? Tell me, anyone? Tell me, guys. Tell me, please. Yeah, tuning. What is the meaning of tuning? Uh, right. Refining to get a result. You are right. You are right. So same here. Same here. Hyperparameter tuning. Also, we are trying to search. We are trying to fix proper algorithms. We are trying to fix proper algorithms. That means here parameters which will be defines like what model architectures we should follow. We should refer to as hyperparameters. We're getting my point. So that's why the concept name is hyperparameter tuning with the grid search. So we'll see here. We'll see here what hyperparameter tuning with the grid search. In above exam exercise, how you know n numbers is equal to 6? Do you have any way to find it? This is the question. How can you know that the neighbor should equals to 6? So let me give one examples here. Let me give one examples here. Let's suppose I want to create I want to create, you know that k neighbors. Let me do more information here. K neighbors, come to that neighbors. So k neighbor classifier is a class. That means class. It takes it initialize neighbor base. That means neighbor base makes. What is the meaning of this? Is what is the meaning of anyone? In let's suppose in class I'm passing some values. What is the meaning of neighbor? Which is the subclass? K neighbor. Okay, okay. So we can see here. For yeah, you are right. Yeah, but in OPS class, I have described here how to extend in this. Let's suppose we have a class A, we have a class A here, and we have a class B here, we have a class B here. If so, if class A, if class A wants class B want to extend class A. So how can you write here? You generally write class B. Okay, right, you are right, and you pass class A here. This is the meaning of class B. Try to extend the class A features. Same as it is, K neighbors classifier extends neighbor base, neighbor mixin, supervised integer mixin, classifier mixin. So you can go through with the class in details here. Classifier implementing the k nearest neighborhoods. I want to see here what is the meaning of parameters first n underscore neighbors. So it is the int optional. Why optional? Because default is equals to 5. If you are not giving any values, it will be default take 5. Number of neighbors to use by default of KNN queries. So let's see here. I want to create one and one values here. Let's suppose we have in numpy also. I want to arrange here numpy arrange. We have a one function is called arrange function. I want to arrange from 1 to 50. I want to take. Let's suppose how we will decide which one is the best. I want to decide first which one is. So how can we do that? How can we, let's suppose I want to decide here I want to take care in our previous session I described here. I want to take, let's suppose, instead of I want to take here instead of k neighbors K neighbors is equals to 8. K, where is K neighbors is equals to 8, where I decide here, there. Okay, so you saw that already here it's not there, but okay, you can see here K neighbors is equals to 8. I want to create one for one loop, even though you can create one loop here, and you can pass 1 to 50 neighbors, 1 to 50, one by one neighbors, and you can see here which neighbors is best giving the results. This is the manual work. You can try with. So let's suppose I want to create here np.arrange 150 150. We have a one and I want to put into that one dictionary here. You want to create one dictionary. Okay, then dictionary key is let's suppose I want to push here n underscore neighbors, n underscore neighbors, neighbors, n underscore neighbors. I want to see here as a dictionary key. Okay, and then the value should be 1 to 50. It will take. Okay, and let's suppose I want to push here. I want to push here this param grid. This is a grid of neighbors. Got it. This is the grid of neighbor I have created here. Let's suppose I want to know that what is this what is this can you try with that. Can you try with that? First create one grid, and then you can pass or should I describe? No, okay, no issue. Let me describe here. uh, I want to describe what is grid, grid search. Same as it is. This is just like a grid. Grid search internally what is happen like let's suppose internally it will be created np.arrange 150 manually, and one by one it pass first neighbor equal to 1, and then check, then 2, then check, then 3, then check, then 4, then check, then 5, then check. You know, so, and then after internally it takes the values. If the accuracy is fine, then it say like, hey, 8 neighbors is fine, 4 neighbors is fine, 3 neighbors is fine. Let me see here what is grid grid search. No, it's not. I want to create one grid search here. Grid search CV. It will work. Okay, no issue. This is the I want to check here grid search. I want to pass in this grid search. We have already. Let me describe one algorithms also that I want to take in from previous session. I want to take it. Let me see here. I can take KNN algorithms. Where is there? Let me take it here. First, I want to execute this one. Then I want to initialize grid search CV. Okay, grid search CV, and then I can pass here. I can pass here KNN. Okay, and then next parameter I can pass here param grid, and next parameter I can pass here. I want to pass here CV. Okay, search CV. Let me describe. One second. Why it's not searching? It should be search. Let me put into that one variable. That variable is called KNNCV. Grid search CV is not defined. Okay, right. So let me define here first how to define grid search CV. Let me input that grid search CV first. How to define that grid search CV? How to import the grid search CV model? Tell me, guys. Tell me. Hey, why? No, but how to import any files like a files in the sense like how to import any module. Yes, so you have to import here. That's why. So how can you do that? From SK learn, yeah, import. Let me. No man, why it's not taking? Okay, okay. One second, one second. Mm, it should be taken here. One second, please. One second. In this system, should in my can anyone try why it's not coming? Why it not coming? Can anyone try with their own system? Anyone try? You are doing practicing or not along with me? Right, right. Anyone can try with the can we have a yeah you are right. This is our model selection. So we can see here what should I write? Tell me what should I write here from scalar. Tell me what should I write here? Venkat, tell me. Yeah, dot model selection. Then I have already. I think we are not using here. No. So that's why actually in previous session already imported. Yeah, dot model selection dot model selection. What is the model? What is the model selection? We can see here grid search. We can see here grid search. Grid search. So whatever whenever you have to here, 1 second. You can see here. You can see here what is the model selection. Like a model selections like I don't want to do anything manually. Yeah, you are right, you are right. Okay, I don't want to do anything manually. Train and test. Earlier I described train and test. I don't want to split. So we have to select a model. That means machine internally select do for you. Same as it is. I don't want to know which neighbors is better. I don't want to know which neighbor is better. So machine automatically do for you. Hey, give me 1 minute, please. 1 minute. Okay, am I audible? Am I audible? Am I audible? Yeah, okay. So actually I have to leave early today. Okay, so I have to go somewhere. From SQL dot model selection dot grid search. Okay, so dot grid search. Then so once once you import grid search, and then what you have to import, then import what is grid search, no module name SQL. Can you try with the in your system? But same things. This is working in my different machine. Can you try with it? No, that would be also. Let's suppose same things. Okay, okay, right. Sorry, that was the different. Okay, so you have to observe here. You have to, yeah. You can see here what is a grid search. You can see what is a grid search. Can you do some analysis? Okay, can you do some analysis here? What is a grid search? Can you do some analysis? You can see here in grid search, we have an estimator, we have a param underscore grid, we have a scoring, we have a fit params, we have a no jobs, we have a refit, we have a CV. So these things I want to describe here. I want to describe CV and CV. So let's see what is a CV here. So once we'll come back here, we can see here in job. I will describe each and everything one by one, but I want to describe here. CV is nothing but this is a cross validation generator or an iterable option. Okay, an iterable option to cross validation is splitting a strategy possible into for CV. That means it will be described threefold cross validation. So let me know that what is threefold cross validation. Before that I want to before that I want to show some analysis here. Then we'll go back there. Grid search. I want to pass here KNN, then param under param grid, then I want to pass here CV is equals to 5, and then before going to that I want to show some analysis, so you will be more and more clarity. Then I want to fit here NN underscore CV, and how to fit your model. We have a fit methods. Okay, and then I want to pass here X and Y. So could you try with the X and Y, because I have to import the X and Y. Can you try with that? Can you try with that? I have to go somewhere. Hey, can you try with that? Your own. Okay. Yeah, just take it here X and Y and fit your model and then try with. Okay. Due to some exigency, I have to go somewhere actually. So I'm not able to focus on learning, teaching actually. Yeah. You can, yeah.